All right, today we're going to look at lesson 3.2, Analyze Graphs of Polynomial Functions. So you can use different approaches to analyze the various behaviors of graphs of polynomial functions. Apply these to study the behavior of a polynomial function. All right, so in the previous lesson, we looked at polynomial functions in standard form. You can see that this function is now in factored form. So we can determine some things from factored form that you can't necessarily see directly from standard form. So let's look and see what we can tell. So it says use algebra to find the zeros of the function. The zeros of a function are those values of x where the value of the function is equal to 0. On a graph of the function, these are placed where the graph crosses or touches the x-axis. The function is given in factored form. Determine what values of x will result in a factor with the value of 0. Set each factor equal to 0 and solve. All right, so x plus 1 equals 0. If I subtract 1 from both sides, x equals negative 1. X plus 2 equals 0. Subtract 2 from both sides, negative 2. Here I have x minus 2 equals 0, so I would add 2 to both sides to find x. So you can find your zeros or the x-intercepts from the factors of a polynomial. All right, we're going to skip this next part here where it says like determine points, like basically it wants you to test points during different intervals of the graph. Most of the time you're going to be using a calculator, so we're going to skip down to the calculator part. If you want to do the last section on your own, feel free to do so. All right, it says use a graphing calculator to analyze the graph of a polynomial function. Graph the polynomial function with a graphing calculator. So I can use my graphing calculator, and let's just look at how to graph that. So let's clear the previous function we had. All right, so if I go and scroll back up, I'm going to look at my factors here, and I've got x plus 1. So I can type it in. I don't have to put it in standard form. I can just do x plus 1 times x plus 2, and then times x minus 2. All right, so you've got x times x times x. If this were in standard form, this would be a cubic function. So you should remember what a cubic function, the general shape of a cubic function, looks like. Okay? All right, so let's go back down. All right, it says graph the polynomial function with the graphing calculator. So that's what I did. I just graphed it using the factors. And even though this has got a scale, this just goes from like -3 to -5, I could change mine to look like that. If I want to change mine, I can make my x's. This is probably like -4. Let's go from -4 to 6. So my x's go from -4 to +6. And then my y's go from, looks like about -7 to +2. So let's do -7 to +2. So you can always change your scale, or you can always change the window in your calculator to match whatever you have. Like if you're doing a standardized test or something and your graph doesn't look exactly like the choices, if you change your window, it's going to look very similar to this. Okay? All right, so let's see what we're doing here. So it says use the trace feature to find the local maximum and minimum. All right, so the maximum is going to be your highest point. Your minimum is going to be your lowest point. So it says confirm the end behavior. All right, so we studied end behavior before. So remember, we're going to the left. That's our negative x's. So as x approaches -infinity, my y value also goes down. So my y is my f of x. So as x goes to the left, y goes down. All right, this says as x goes to positive infinity, so this is my positive x's. As it goes positive, you can see that the graph goes up, so that goes towards positive infinity. All right, and my local maximum comes from this point right here, so that's at negative 1.535. Make sure that's the same point up there. All right, looks like it. And then my local minimum is going to come from the lowest point, which is 0.869, and negative 6.065. All right, so to determine the maximum and the minimum, you can do that by looking visually at the graph. All right, it says you can analyze the characteristics of the graph of a polynomial function to solve certain real-world problems. Lawrence is creating an open-top box with 10-inch by 14-inch regular piece of cardboard by cutting an x by x square from each corner and folding the side up to create a regular box. What value of x to the nearest tenth maximizes the box's volume? All right, so you can see that if you, these are dotted lines here, but if you cut that, these are going to fold up. So this inside part here is going to be the bottom of the box, and then these will create the sides of the box. All right, so it says the dimensions of the piece of cardboard are given. Use the information to write expressions for the length, width, and height. All right, so the length here is going to be that 14 inches minus 2x. So the length is going to be this whole distance, which is 14 plus 2x, but when you fold the sides up, those will no longer be part of the length, so that's why it's minus 2x. The width of the box, the same thing, is going to be 10 minus the 2x. And so the height of the box will be, when it stands up, it will be x tall. We don't have to know what x is right now, we just know that's what it's going to be. All right, so write the function, determine the domain. So you know that volume of a rectangular box is going to be length times width times height. So we can determine that the function is going to be, and all we're doing is taking the length, the width, and the height that we just found, and we're plugging those in. So 14 minus 2x, 10 minus 2x, and they already have the x for the height of the box in there. All right, so it says the dimensions must be positive. Use the expression of the width to determine the realistic domain. All right, so we know that the width is going to be 10 minus the 2x, and they already have it. We have it like right here, width 10 minus 2x. And we know that has to be greater than 0. Why? Because we're talking about the length, and length can't be negative. Length is always positive. So if we look at, let's see if I can get my pen here working. So if we look at 10 minus 2x greater than 0, and we're going to subtract 10 from both sides. We've got negative 2x greater than negative 10, divide by negative 2. Remember, when you divide by a negative number for an inequality, it switches the sign. Negative 10 divided by negative 2 is positive 5. All right, so we know the domain is your x's. We also know that the dimensions cannot be negative because it's a length. So it's going to go from 0 to 5. All right, so if we look at, it says use a graphing calculator to find the maximum of the domain. All right, so you can see the maximum is here at 1.918 and 120.164. So it says at this point, the graph has a maximum value. The box will have a maximum volume of about 120.2 inches cubed when x is about 1.9 inches. All right, so that's just using the information we're given to locate the maximum, and these numbers come just from the vertex or the maximum value. All right, so that is a little bit about analyzing graphs. The big thing is practice with your graphing calculator and make sure you know how to graph quadratics, polynomials, different types of functions in your calculator, and also be able to change the window so that you can analyze parts of the function. If you have any questions, let me know.